So I'm going to give you a quick overview of Diptrace today. So here's our Diptrace schematic software. And one of the nice things about Diptrace and any of the schematic softwares that you use that allow you to circuit boards, so Eagle's another one, Ultima is another one. You create the schematic in the software, and then you create a circuit board, and the two connect together. And one of the nice ways to make that work really well is if in the schematic software you put the sizes of all your components. That way, when you import it into a circuit board side of the program, everything's sized correctly. So if you wanted to, you could draw the schematic first and then change all the components. But I find it easiest to know what my component size is to start with and then choose those correct components. So here's the schematic we're going to use. I'm going to start with C1 just because it's sitting there. And here is C1 from DigiKey, which is one of the big suppliers of electronic parts. So this is what the capacitor looks like. Since these are high voltage capacitors, this is actually a pretty big one. And here are the specs I need to know. So the physical size of it is 18 millimeters by 6 millimeters. And then the pins are 15 millimeters apart. So those are the things I'm really interested in at this point. So I'm going to push that over to the side, and I'll go ahead and pull this capacitor on. And so this is a film capacitor. This right now is my library. So I have a lot of components already created in my library, moved in from the main library, or I've created them just on my own. And I'll show you how to create one. So for film capacitors, I don't have anything that's actually that big. I have, looks like 8 millimeter is the biggest film I have. So that's 8 millimeter lead spacing, and I need it to be 15 millimeters, which again is a really, really big capacitor. So I'm going to go ahead and search for it in the other set of components. So if I go up here to where it says use your components, I switch that to components. This is going to be all of the components that Diptrace includes when it starts. And there's some ceramic ones here, or excuse me, some capacitors here. So I can look and see if there are film capacitors. I don't really see any that are going to work for me, which is not unusual when you look at the capacitor section. But if you go down, and this is kind of laid out oddly, but there's another set of components we can look at. I got to find it. So the general non-IPC is the place I usually start for this sort of stuff. And then we have all these caps. So these are all the sort of regular film capacitors. And then down here at the bottom, so this shows my schematic symbol, which is all going to be the same for these. And then down at the bottom, we see the actual layout, what's going to be the outline on the circuit board itself. And so this is 10.16 by 14.2 times 3. So that tells you a little bit about the size. And so we'll see if we get one that's 18. So now we've changed to a different style. So I might be able to find these if I kept looking, but it's probably going to take me a lot of work. So I'm going to make one instead. So I'm going to go back to my list of components and go to a film capacitor. So this is a schematic symbol I want, and that's the basic outline I want. It's just not the right size. So once you have a component that you want to use, get rid of that, I didn't want that there. I can click on this, drag it out into the board, and put it somewhere. So I'm going to go ahead and go create the component. And I think this is worthwhile because if you have to create a component, you can spend a lot of time searching for the right one, and it doesn't really take that long to create one. So I'm going to go up here to Tools and open a different version of the software, which is the component editor and the pattern editor. So the way these two work together, the component is this part right here. It includes a schematic symbol, but it also attaches to the pattern. So the pattern is really the thing I want to create, because I'm going to use this schematic symbol. I'm just going to create a new pattern for it. So I'm going to start by going to the pattern editor. And this is all included when you install Diptrace. It's just a different section of it. And I'm going to go ahead and start with that film capacitor that I had, 8 millimeter film, because it's roughly the right, it's the right shape at least, just not the right size. So here are my two holes. Those will be the leads, where the leads will go. Now I just want to move them to be where they're supposed to be. So I need my lead spacing to be 15 millimeters. So I'm going to double click on those, and I can show my size. So it is 4 millimeters from center. So they're 8 millimeters apart. So I want them to be 15. So I'm going to go 7.5. And get the other one and do it positive 7.5. Now I might want to check that the size of the leads is still going to work. I'm looking to see if this lists the size of the leads. It does not. So this is, I'm looking at the page just in the DigiKey where I ordered it from, or where I would be ordering it from. The other thing you can do if you want to know that for sure is go to the data sheet. And once you go to the data sheet, it's going to open a different document. This is probably for a big series of capacitors. So you want to make sure you keep in mind the part number you were looking at. So we want to make sure that stays open. So I've got both pages there I can reference back. And sometimes it's going to be just the lead spacing will tell you how big the lead is. But we'll have to see how that works for this particular component. So usually there's a drawing. I don't see one. So we'll have to look and see if there's anything else we can find. Lead length. I don't care about that. What I want to know is really lead diameter. Okay, here we go. So that's going to be little d is going to give us that dimension. That'll be the diameter of the lead. So now with the component I'm looking at, and we have a 0.1 microfarad 560 volt, or 250 or 560 volt. So we'll see how which way that's listed as. So it'll be the 250. I don't see 560 listed, so it's here. And find it. It's a 0.1. Okay, there it is, 560 volt. So that's a little bit of an odd part, but it's the one that we're going to go with for right now. So little d is the dimension we're looking for, and I don't see that listed. So that's not unusual. I didn't intentionally pick one that was going to be difficult. This is just the first component I saw. Okay, so here we go. It's either going to be 0.8 millimeters or 1 millimeter. So we can go ahead and say, let's say it's the bigger of the two, and it's 1 millimeter. So we just want to make sure that our hole size is a little bit bigger than 1 millimeter. So let's see what it is. We'll double click again and go to type and dimensions, and we see standard pad properties. So this whole component has one set of standard pads, and all the pads will match this. So let's see what this is. And so the hole diameter is 0.9. So that's not quite big enough, possibly, depending on which size we're going with, right? So we need it to be 1 millimeter. So we're going to make that a little bit bigger. That won't be too big. So we'll do 1.1, which should be fine. So, okay. And that changed both of them. If this ring size looks too small to you now, you can go back to that and we can say, well, let's make that a little bit bigger. Let's make it 3. There we go. And now the capacitor itself is a little bit bigger than this outline, this rectangle. So we'll go back to that document. And it is 6 millimeters by 18 millimeters. So we can click on this box. We want it to be 18 millimeters wide and 6 millimeters tall. And there we go. So now we've got our outline that shows us how big the capacitor is going to be. And that's useful because we don't want to put anything else within those boundaries. Now, I totally messed up. Not intentionally, but I should have duplicated this before I started doing all these changes. So I'm going to go undo all those. Actually, what I can do, so if this happens to you, easiest thing to do is to grab this all and copy it, and then undo all the changes you made. So now we're back to, let me make sure it's back to where it was supposed to be. Nope, still, there we go. That's what it's supposed to be. Now I'm going to go over here and right click on it and duplicate it. And then make sure I rename it. This is actually now 15 millimeters. Okay, good. And then I can delete all this and then paste what I copied earlier. So you can tell I've done that a number of times. So that's all ready now. I'll just save to save my library. So now this is in my library, this 15 millimeter cap. And I just create them as I need them. And then next time I need it, it's already here. So now I want to go to the component editor and do a similar process. Again, I'm going to go find that 8 millimeter capacitor right there. I'm going to duplicate it. I right clicked to get to this. Rename it. 2 millimeters, good. And now this schematic image I don't really care about. That's going to stay the same. But the pattern is what I want to change, and that's what I just created. So I'm going to click here on pattern. And then over here I want to select user patterns. Go to my library. And then you see here below 8 millimeter is that 15 millimeter you just created. And if you're creating these, one of the things you can do is pin one of the capacitor. And in this case, this is a non-polarized capacitor, so there's no real difference between pin 1 and pin 2. But this shows you which of the two is pin 1, which of the two is pin 1, is pin 2. And that's really useful, particularly if you're doing transistors or things. You want to make sure the pins are where you think they are. So okay, and we'll save this library again. So now when I go back to my circuit program, it's sitting there. And I can bring it over, put it there, double click on it. It's C1, which is what I want it to be, put its value in, which is 0.1 microfarads. And that's ready to go. Now, based on the schematic that we're copying, it's sitting at a right angle. So while it's selected, if I hit R on my keyboard, it turns 9 degrees. And I can do this as many times as I need to get what I want. So that one's in. Now I'm going to go ahead and add all the other components in a similar fashion. And then I'll get back to talking you through the rest of the process. So now that we've got all the components put in here, I'm going to go ahead and connect everything. So I just hold over until my connection turns red on the component, and then I can click, drag over and click again to connect it. If you find that you reach up here and you don't get that red, right click and you can go back to that. So I'm going to start making my connections. So down here, lots of things connect to this bottom area. Not that though. I'll do about that. So I'm going to connect here. These two connect, and then that also connects to pin 6 here. And this is actually ground. So I'm going to go ahead and come over here and grab ground. Put my ground symbol there. And then any place where lots of things connect are called nets or networks. So this is net 1 right now. I'm going to right click on that and change its name to ground. Just makes it easier. And then change my wire color to green. I just like that. Makes the schematic look a little bit more clear and easy to read. And then go up here, and that's what I want to use to draw. So I can either use this. So I just connect all this to ground. Make sure I get all my schematic right. And then this one also goes to ground. Orange from the transformer goes to ground. And then also pin 3 over here goes to ground. Move this over a little bit. This is my output connector. And then I'll just keep connecting things. This goes right here. I'm going to move that down a little bit so it aligns right. There we go. And then these 3 connect. This goes just over to here. Oh, and that does not connect to there. That's wrong. Messed that up. So I do want this to connect to ground though. So here, if I just drag it over like that, it's not actually connected. So I'm going to get rid of that and redo that wire. Now it's connected. And if I put my cursor over, you see it highlights everything in blue. So I know what everything on that net is. In this case, it's green, so it's fairly easy to note. And then this 100K resistor actually goes to the positive voltage coming from my XLR, which is pin 4. So go ahead and take that over. Again, I know that's positive voltage, so I'm going to rename that. And I'm going to make it red. This is optional, but certainly on a complex schematic, it really, really helps identify it. Just like we talked about last semester, adding the highlighting to your schematic. This way you can do it actually in the software. And then all of these connect. And this one, this goes, oh, I messed up over here again. So this does not connect. Get rid of that. And those 2 connect together. And also to, oh no, this one does go to ground. And then this one comes over here and connects to here. There we go, like that. And I'd probably move that up here and make that look a little bit better. There we go. That looks good. And then this goes over to pin 5 or XLR. There we go. And then 1 and 2 just come right from the output transformer. And then we just need to connect this one, and this goes right up to the anode. And there we go. So that's our circuit. Oh, one connection I didn't get up here. There we go. And that should be it. Oops. So if you find you do that, you can just cancel. So there we go. That's our schematic drawn for this. And each of these components are set up to be what we need them to be on the circuit board. This tube is a special kind of tube that doesn't plug into a socket. It has leads at the bottom. So its pattern is actually just a series of connections on the board where those wires from the other tube, from the tube, will go. Same here with this. This is, let's call this J out. This is the 6-pin output connector. This LDC up here are the 2 connections for the diaphragm.